Hi students, this is the last video in this closed curve section. So let us go back to the first figure that I draw. Is it not there? I think I erased it. Yes. So let us draw a fresh diagram. So look at this diagram. As we mentioned, this is not a closed curve because if you start from this point, you cannot reach back at that point again. You will trace like this only. But if you start with this point origin, then you can reach back at the origin. So origin is called a self-intersection point. So what is a self-intersection point? So let us define it. So a parameterized curve. Let us say curve. Curve means parameterized curve. Gamma is said to have a self-intersection this is self-intersection at a point P of the curve if there exist parameter values a not equal to b, such that one gamma of A equal to gamma of B. Which is the point P. So at two different instances A and B, the curve reaches the same point. Like this. At two different instances, the curve reaches the origin. And 2. If gamma is a closed curve with period t, if gamma is a closed curve, closed means periodic. That's our definition. With period capital T, then this A minus B, that must not be an integral multiple of t. Must not be an integral multiple of t. Multiple of t. So the condition 2, is that applicable in this figure? Is that applicable in this figure? Condition 2 says that if gamma is a closed curve with period t, but this is not a closed curve. So can you give me an example of a situation where condition 2 is also applicable? And you want to look at how a self-intersection point on that curve will look like. For example, let us take the figure 8 in the plane. So let us start from here. After time small a, I reach this point. Let this point be capital P, and after time b, I again reach the same point P, this point. Then when the period is completed, it reaches back the original point here. So this a minus b is not an integral multiple of the period capital T. So this is a situation where condition 2 is applicable. So if one holds in this case, then this is a self-intersection point, and if 1 and 2 holds in this case, then this is a self-intersection point. That's what. Thank you.